Today we are resuming quadratic functions. That's from your booklet, Unit 4. So we've completed characteristics of quadratic functions, and we looked at the vertex, we look at the x-intercepts, and the range. We'll use that set of information and apply it to solve real-life problems. So there are 4 sections in lesson 2. The first part, quadratic applications with a graph given. So you're given the graph and you're asked to interpret the graph. It's a graph that represents a real life situation. The second set of problems dealing with when you're given the equation. The first one, the graph is given. The second one will be the equation given. Then the table of values given. And finally, verbal descriptions given. So we'll be going through your booklet, and you look at examples 1, 2, and 3 today. And for this, you will need your graphing technology, such as Desmos or your graphing calculator. So we'll be utilizing these. Also, you may want to have handy with you your calculator instructions for the graphing calculator and how to display data and find line of best fit using Desmos. We're also going to use this for quadratic functions also. So let's look at the first example. In this example, you're given a graph, and the graph represents a ball kicked into the air. And this graph shows you the height of the ball versus time. So here's our graph. This is your time. So you kick the ball in the air, and after 3 seconds, it's fall back to the ground. Now, this could be straight up, but generally speaking, when you kick a football, it will go away from you. So this would be the trajectory or the path the ball will take. So it's your time, and this is your height. So we are going to answer the question based on this graph. Remember your x-axis and your height, your time is in seconds, and your height is in meters. So we can say this is time 0. So this is the time the ball is in the air from the time it leaves the ground, goes up, the highest point, then it comes back down. Notice this has a parabolic shape, which is a quadratic function. So the first question, how long or how many seconds is the ball in the air? To find how long the ball is in the air, we look at the point, the time, beginning of time. The ball is kicked from time 0, goes up, and it lands to the ground, or someone catches it, at 3 seconds. So this is the time the ball is in the air, from 0 to 3. So we say the ball is in the air for 3 seconds. The maximum height now would be the vertex. Remember we talked about vertex? So here we have the vertex of the parabola. Now, if we were to have a straight line and it be approximately 4.5 seconds. So the y value here, 4.5 seconds. Sorry, this would be a height, 4.5 meters, not seconds, meters. Looking at time in a minute. 4 meters. 4.5, sorry, 4.5 meters. Make sure I got this written down properly. So 4.5, yes. Now the time the ball reaches the maximum height, now we go straight down, and that will give you a time. So you're looking at the maximum height, and to find a time, it's 1.5 seconds. 1.5 seconds. So if you were to look at this point here is 1.5, 4.5. So that's your vertex. So the vertex tells us the time and the height. And that's the maximum height. And the time would be your x coordinate. The next part, what is the minimum height of the ball? Well, at ground level, so this is 0 here. So 0 meters. Ground level. The next question now, you require that you use your calculator or Desmos. So we will go ahead and we're going to use our graphing calculator first. So you're playing golf on the moon. Well, that's an interesting scenario. You hit a ball with your golf club. The height of the ball, h, in meters with respect to time in seconds, can be modeled by the equation. So h is equal to negative 0.8 t squared plus 40 t. Remember, t is your time, and h is the height of the ball. So let's do a sketch, right? A sketch of the graph first, right? And here we have, and time will be in seconds here. With seconds. So we have 0 here, and we have our s in time. Now I'll need some more space here, so notice here. So time in seconds. Here we have 0. Okay, and we have our h here. So height, and this is in meters. We have 0 here. Now, so we have our time, and I'll probably make this 25, maybe 50. I don't know yet. I will use my graphing calculator and do a sketch. And from my graph in my calculator, I'll do a sketch. So let's enter into a calculator the equation. Now this we transfer to y is equal to negative 0.8 x squared. Now we change, because your calculator doesn't, well, it does have it, but it's rather complicated. So we leave it as x squared. We continue using x as for time. So I'll go straight to my calculator here and enter. Okay. So first of all, I'll go back and reset my calculator. I'll just zoom out here so you can see. So I'll reset my calculator because I have some data from before, and it may disrupt some of my calculations. So I'm going to, okay. So to reset your calculator, second and plus sign. So, okay, let's go back to home here. Now, whenever you see your screen has a lot of data, you can go back to the home button, as they call it, by pressing the second and mode. They'll mean quitting what you have here. So I need to go to my memory. So second, and I want to reset number 7. Press enter. I want to reset, press 2, and that clears everything. So now I want to go to my y equal button, and I want to enter my equation. Okay, so I'll start off. Okay, make sure I put this all 40x. Okay, so y is equal to negative. Remember, use your negative button here. Do not use the subtract sign for a negative 0.8x squared plus 40x in a graph. And when you enter your equation and press graph, you will not see much. You'll see this line here in my calculator. Okay, so I'll just fix this. Difficult to see. I'm going to just zoom in a little bit here. Maybe I'll turn off the lights here. That might make it look better. Okay, there we go. Notice you don't see very much here. So what you want to do is to change your window. Remember this, we said is a quadratic, you don't see much. So change your window. Notice my window setting here is from -10 to 10. So if I go back here, -10 to +10, -10 to +10. I don't need these negatives because we're only dealing in quadrant 1. So I don't need 2, 3, and 4 quadrants. So I'll go to my window, and I'll adjust my window. I'll make the minimum 0. I'll increase the maximum. Okay, I'll make the maximum maybe 100. See what happens, right? And then I go back to my y minimum, 0, and my y maximum, I'll make that 100. So my x maximum and my y maximum 100 each. Now let's press graph. Now I can see my parabola going down here, but I don't have enough on my y. So go to my window again, and this time my y, I'll make that maybe 500. And there you can see your parabola. There's another way of doing this. You can press your zoom button and 0, and it will zoom into it. But at this stage, we can simply use our window button and play around with the window. Now, I still would like to see more above the vertex. So I'll go back to my window, and I'll increase my maximum here, y maximum, to maybe 700. And that will give me a better view of my parabola. So here I have my time and this is the height of the golf ball. So now I can do a sketch of that. I'm going to go back to my booklet. And now I can enter the sketch into my graph. Okay, so I know. Now I don't know the height yet. So let's go ahead and find the height. Now you can find the maximum height here by finding the vertex. And then we can find the time here. Okay. So let's find our vertex. Now to find the vertex, you can go back to your instructions in your handout here. So we need to find our vertex. We know our graph, right, roughly goes up like this and come down. We want to find this point here. Yeah. And we'll see, I approximately is 50. I'm not sure yet. I'll find that. So let's find our vertex. So we'll zoom out here, and we're going to find our vertex here. Okay, let me zoom out here a little bit. Okay, so we need to find the vertex. We'll move this down a little bit here. So we're going to follow the instructions here to find the vertex. By the way, this is also in your booklet on page. If you go back to your booklet, you're going to go back here. If you're, those of you who are visual, who like the visual representation, it's on this page here. So maybe we'll use this here. It's on page 6 of your booklet. So it says here, enter your equation into your calculator, which we did. Now this parabola is going up. So now we want a maximum value here. So we'll press your second trace button and go to maximum. Now we say left bound, I'll move to the left. Press enter, then it's the right bound, I move to the right of the vertex. Press enter, and one more time, and that's your vertex. So at 25 your time there is what, 25 seconds? The ball is at a height of 500 meters. So let's go back to our page here. So this is the midpoint. So this is 500 here. Zoom in. This is the trajectory of the ball, come down back. So this point here is 25,500. Now you can tell that the ball will be down here at 50 because at 25 it is halfway. So complete would be 50 seconds. Show the vertex and intercepts. Now the intercepts here would be 0, and let's find the other one for sure now. Okay, so now we found the vertex, 25,500 of our vertex. we need to find your x-intercepts. Okay, so let's go ahead. Now to find our x-intercept, we go to my y button, and I go to y2, make that 0. Because there is my... Now I need to find these two values here, the x-intercepts. So let's go to the first one, trace. I want to find intersect. So I press enter 3 times, and there it is, 50. So it's going to look a little messy here. Let's change that home. So this is 25, so this is 50. This is one of your intercepts. The other intercept, we go second trace, find intersect. Now this time I'll move over to my left by pressing the left arrow key. And I go all the way down close to, yes, here. And I'll press enter 3 times. And there it is, 0, 0. So those are my two intercepts, x-intercepts. Show the vertex and intercept, so the intercepts are 50, 0, and 0, 0. So we can put here intercept. Zero and 50. By the way, to help you down the road, we can actually look for a window. What are our window setting? Now I'm going to make this 0 back here. Maximum. Make that. We had it 100. Make that 60, maybe 60. You can make it 60. Looks better. Here's a trajectory. And we know our vertex. So that's our, so we can put our window down to, so the window where you have x minimum is equal to 0, x maximum is 60, y minimum is 0, and y max equal to 700. So that's your Windows setting. Now, what's the maximum height to the ball? So that's the y value of the vertex. So how do you do that? You find, which we found the vertex, find the vertex, right? The y value is the maximum height. Which is equal to 500 meters. Now the x value gives you the time, so the x value of the vertex. Let's put here, x value of the vertex, the time, in this case 2.5 seconds, ball reaches its maximum height. Now the last part here, for how long, how many seconds was the ball in the air? Now the balls hit at this point time 0 reaches a maximum height of 500, 2.5 here. It's 25, sorry. Should be 25, should be 25 seconds. Get it back to a graph. See whether that be. Yes, that was 50 seconds. Okay, right. So 25 seconds. At 25 seconds, the ball reaches its maximum height. Okay. For how long was the ball in the air? So the ball was in the air for 50 seconds because the time from hit the ball is 0. It'd be 50 seconds. So 50 seconds ball in the air. If we were to do a sketch of the graph, so it goes up, comes on back, here is 0, 50, and here is 25. This is time in seconds. This is your height in meters. So this is your 500. So once you know the midpoint, which is your vertex, then it's halfway between the beginning and the end. So from beginning to the midpoint is the same as from the midpoint. The time from beginning to midpoint is the same as the time from midpoint to the end. So that's why I could predict it's 25, it'd be 50. So if this was 100, then this would be 200. Double it. Okay. Now, if you were to use Desmos, the same principle would apply. Desmos. So we'll have our equation in Desmos. We have y equals a negative 0.8x squared plus 40x. Okay, now we go to a home button. No, you said that. Okay, now you pinched. In this case, instead of using this, there's our graph. Your vertex, you tap on it. So that gives you your 25, 500. And your x-intercepts, you tap at 50 and 0. Okay, we look at one other example. Where the equation is given. So a water arch at a splash pad is defined by the following function. So we have yv, or y is equal to, or v is equal to negative 0.15x squared plus 3x, where x represents the horizontal distance and v represent the vertical distance. Okay, so let's do a little sketch here. So V, so we have our X here. So this is a vertical height. Let's see, vertical distance. So we have a vertical distance here, and then on our x-axis, we have a horizontal distance. Until they're in feet. Horizontal distance is feet, and vertical distance is also in feet. So we'll start off from 0 here. This time we'll use Desmos to start off. Now we'll enter this into Desmos, and then we'll find the vertex. So here we need to find the vertex. And this will give you the maximum height. The y value is the y value of the vertex. The maximum height. Okay. So let's go back. There's my so clear. But now the v, remember this is going to be equal to y is equal to negative 0.15x squared plus 3x. So let's go ahead and enter that equation. So y equals negative 0.15x squared plus 3x. So there's our graph. Now, tap in there, that gives us our vertex. Tap will give us our x-intercepts. So I'm going to transfer that over to my graph here. So my graph goes up here, comes up. So here's 10. This would be 20. Oops, I think it's off center. And it goes up a height of 15. So we have 5, 10, 15. So my point. So this point here is 10, 15, and here we have 20, 0, and 0, 0. So this is our axis of symmetry right down in the middle here. It divides it up. So this is 10, and this is 10. So let's go ahead and answer our question. The maximum height. So the maximum height is 15 feet. How far So here we have, first of all, you find the two x-intercepts. So find the two x-intercepts. In this case, it is 0, 0, and 20, 0. The difference between the two x-intercepts is the opening the ground the water can reach. In this case, it is 20 feet. So put that here, 20 feet. So in other words, the water, if you look at this picture here, it goes up and comes down back. The distance here is 20 feet. So if you're within 20 feet, you'll be drenched by that splash pad. So these are three examples we looked at today. And the first example was applying when we given the graph. And the other two examples when you're given the equations. Okay. So your task is to assign me 2 complete questions 1 and 2. So for practice questions, complete these 2. The next lesson, we'll be looking at application of quadratic function when the table of values are given.